All right, let's take a look at the practice test, where the instructions were asked to find the vertex, focus, directrix, and endpoints of the latus rectum. All right, let's take a look at the first problem. So we are given y equals 1/2 x squared plus 8x plus 26. So from our knowledge of parabolas, we know that this is a vertical parabola because we have x squared right here. We also know it opens up because the coefficient of x squared is 1/2, which is positive. So what I'm going to do is manipulate this guy right here into this form right here, and that will allow me to find the focus, the directrix, and also I'll get the endpoints of the latus rectum. So really this isn't too bad. It's kind of tedious because you do need to complete the square. Let me slide down here a little bit, and I'll just copy this. So let's write y, I'll put a little space here, equals 1/2 x squared plus 8x plus 26. If you need this right here, I would copy it down because it's going to go off the screen. And I'm just going to start by getting all the terms with x involved on one side, everything else on the other. Because again, you're going to want to complete the square, so you end up with this binomial squared right here. So let me go ahead and subtract 26 away from each side of the equation. And I'll say that this is going to cancel over here. And so I'm going to write y minus 26 is equal to 1/2 x squared plus 8x. Now again, if I'm completing the square over here, remember you want that coefficient of your squared variable, in this case that's 1/2, you want that to be a 1. So what I'm going to do is multiply both sides of the equation by 2, since 2 times 1/2 would be 1. Let me see if I can slide this down and make this fit. So this right here is going to get distributed to each term inside the parentheses, and this as well. And let's slide down a little bit and just say that 2 times y would be 2y. And then minus 2 times 26 would be 52. And this equals 2 times 1/2 is 1. And then times x squared would just be x squared. Let me fix this symbol here. And then plus 2 times 8x would be 16x. Now here's the step where, again, a lot of people get lost. Just remember you're looking at the coefficient of x raised to the first power. So that's 16. And always take the sign with it so it's positive 16. So this guy right here, you're going to cut it in half. So 16 times 1/2. And then you're going to square that. This right here that you get from cutting it in half, 16 times 1/2 is 8. That's what you're going to use when you factor. So remember that. So this is going to end up being positive 8 squared, which gives me positive 64. So what I'm going to do, just remember this 64 right here. I'm going to add that to both sides of the equation. That's going to complete the square over here. Again, it's going to give me a perfect square trinomial, which I can then factor as a binomial squared, so I can match that form from above. So let's say this is 2y minus 52, and then again plus 64. Is equal to x squared plus 16x plus 64. So I added 64 over here, and then I added 64 over here. So I didn't do anything illegal. So on the left, you're just going to simplify. So 2y minus 52 plus 64. Well, negative 52 plus 64, that's 12. So this becomes 2y plus 12. Over here, this factors into the quantity x plus 8 squared. Again, how do I know that? Because I'm taking half of this guy right here and putting it right here. That's how that works. So the last thing I'm going to do is factor out the coefficient of y, which in this case is a 2, just again to match that form. So you're going to have a 2 out in front, and this is going to be times the quantity y plus 12 divided by 2 is 6. So this equals the quantity x plus 8 squared. In order to make things match completely, I'm going to switch sides. So I'm going to say this is the quantity x plus 8 squared is equal to 2 times the quantity y plus 6. And I'm also going to change this over into minus a negative in each case. Again, just so we don't get confused about what the h value is and what the k value is. So this is going to be x minus a negative 8, quantity squared, is equal to 2 times the quantity y minus a negative 6. Now, you don't have to take this step, but I find that if you do it, it's less likely you'll make a mistake. Okay, so let's paste this in here. And again, the idea is to match things up. So we want to figure out, well, what is h? This is h right here, so this will be h right here. Again, this is a minus, and this right here is a minus. So make sure those guys match, then this right here is going to match with this guy right here. So your h is equal to negative 8. Then your k, again, this matches with this. This is a minus, this is a minus. So your k is going to be negative 6. Let me just draw a little arrow like that, and let me write that k is equal to negative 6. Now, you also need to figure out what the p-value is. To do that, you're going to match this up with this. So you're going to solve the equation. 4p is equal to 2. So let's divide both sides of the equation by 4. So this cancels, and you're going to get p equals 2 over 4, which is 1/2. So let's write that p is equal to 1/2. All right, at this point, we need to figure out what is the vertex, what is the focus, what is the directrix, and then what are the endpoints of the lattice rectum. So it's very easy to do just using this little table. So let's write everything down, and then we'll go back up and explain again where this is coming from. Something we covered in the lesson, but we'll just do a quick review on this problem. So we're working with a vertical parabola. So we're going to be on the second row right here. This is the form of our equation. So the vertex is going to occur at h, comma, k. The focus is going to occur at h. So the x-coordinate is the same as the vertex. And then comma, k plus p. So I'm going to take this y-coordinate of k from the vertex, and I'm going to add that p. Let me fix that. And then for the directrix, since this is a vertical parabola, we're going to have a horizontal line. So let's put D for directrix, and it's going to be y is equal to, again, you're going to use that k value, that's your y-coordinate from your vertex. You're going to start with that, and then you're going to subtract away p. Now, in terms of the endpoints for the lattice rectum, I'll do that last. Let me just get this out of the way first. Okay, let's come back up here and paste this in. So I'm just going to go through this, and then I'll explain where the formulas are coming from, just to give you a little review. So let me put a little border here, and we're just going to go through and fill things in. So the vertex, again, is h, comma, k. H is -8, k is -6. So this is -8, comma, -6. The focus, again, is going to be h, comma, k plus p. Well, again, the h value is -8, and then the k value is -6, and the p value is 1/2. Now on the graph, you're going to see that I use decimals because that's what the program uses. But as a personal preference, I like fractions. So you can do it either way. You can do, let me just maybe slide down a little bit. So you could say -6 plus 0.5 if you want to convert that to a decimal. And this would be -5.5. Or if you want to work with fractions, you could say -6 over 1 and then times 2 over 2. So you have a common denominator plus 1/2 would be equal to -6 times 2 is -12. And then over 2, and then plus 1/2. So -12 plus 1 is -11. And then over the common denominator of 2. So -11 halves or -5.5, those are the same. It's just what you want to use. It's up to you. It's personal preference. So I'm just going to stick with fractions right here. So -11 halves. Okay, for the directrix, again, this is a horizontal line, and it's going to be y is equal to your k value, which again is going to be -6, and then minus your p value. P is 1/2. Let me fix that. So if you want to work with decimals, you just do -6 minus 0.5. So that's -6.5. So you get y equals -6.5. You'll see that when we go to the graph. If you want to work with fractions, again, you could write -6 as -12 over 2, and then you subtract away 1/2. So this becomes -12 minus 1, that's -13, over the common denominator of 2. So you can write the directrix as y equals -13 over 2. All right, let's do this first one without our formulas. And I think it's a good exercise just in case you don't have the formulas handy and you're trying to solve one of these problems. You can just come up with the formula on your own. So this is specifically going to work for a vertical parabola. But again, you could think about this in a similar way if you want to get the formulas for the horizontal parabola. First off, we have that our p is equal to positive 1/2. So remember in the lesson we said that p can be thought of as a directed distance from the vertex to the focus. So in our situation, because we have a vertical parabola, if the p value is positive, that tells me that the parabola is going to open up, because from the vertex to the focus, remember the focus is on the inside of the parabola, I'm traveling 1/2 of a unit up. Then if I had a negative p value, well, for a vertical parabola, I'm going to open down, because from the vertex to the focus, I'm traveling down. The focus is on the inside of the parabola. So what we would think about is, if you want the formula for the focus, start with the vertex. So we know that this is h, comma, k. In this specific situation, this is going to be -8, comma, -6. Well, if I think about getting the focus, again, how do I get my formula? Well, I know for a vertical parabola, I'm just traveling vertically by p units. Again, that's a directed distance. Here it's positive 1/2, so I'm going up by 1/2 of a unit. So what that tells me is that the x-coordinate from the vertex, which is given by h here, is not going to change. So I can just copy that. And then in terms of the y-coordinate, well, I start with whatever k is, and then I can just add whatever p is, because again, it's a directed distance, so just add p. In this case, for the focus, we have -8. Again, that comes from just copying this x-coordinate right here, and then comma, -5.5, and that comes from me taking this -6, the y-coordinate from the vertex, and adding, you could say 0.5 or 1/2, and that's going to get me to that y-coordinate of -5.5 or -11 halves. Now, if you want to get the formula for the directrix, Again, just go back to the definition. If we think about for a parabola, the vertex is a point on the parabola. So if I go half of a unit up to get to the focus, that means I'm going to go half of a unit down to get to a point on the directrix. So this right here, if I started at -8, -6, and again, I went down by half of a unit, well, I'm going to be at -8, -6.5. That comes from me just taking this y-coordinate of -6 and subtracting away a half or subtracting away 0.5. So that gets me a y-coordinate of -6.5. We know that for a vertical parabola, the directrix is a horizontal line. On a horizontal line, all the y-coordinates are the same. So you can just say that this right here would be y is equal to whatever the k value is, so whatever the y-coordinate is for the vertex, and then minus whatever p is. So minus whatever p is. Notice how this right here is k plus p, and then this is k minus p. That's a good way to remember the formula. Then if you look at this specific situation, what you end up with is just y equals -6.5, or you could say y equals -13/2. All right, so how do we find the endpoints for the latus rectum? Again, let's just start with the basic definition of the latus rectum. So it's a line segment that has endpoints on the parabola and passes through the focus and is parallel to the directrix. So let me put an endpoint in right there. So I'm just going to label this and I'll talk about where these are coming from. So this endpoint right here is going to be -9, -5.5. So -9, -5.5. And then this endpoint right there, that's going to be -7, -5.5. Now, without looking at it, how could we get this? Well, you're going to end up coming up with this formula, which is to start at the focus. And for a vertical parabola, you're going to move to the left by the absolute value of 2p. And then you're going to move from the focus to the right by the absolute value of 2p. And in this specific situation, remember that p equals 1/2. But where does that come from? Well, essentially what you're going to look at is this right here. And if you think about this line segment right here, what is the length of that? It's going to be 1. Where did I get that from? Well, because this right here, remember, is a directed distance if you think about traveling from the vertex to the focus. So the p value there is 1/2. So this right here is 1/2. And then similarly, we'll just think about the length of this guy right here as being 1/2. So essentially, this is coming from 1/2 plus 1/2, which is 1. Or you could say p plus p. So p plus p is going to be 2p. So that's going to be the length of this line segment right here. It's 2p. So here, p is 1/2. 2 times 1/2 is 1. So if you look at this right here, this is going to be 2p. And then based on the definition of a parabola, if it's from this point right here to this point right here is 2p, well then from this point right here to this point right here, which is your focus, that's also going to be 2p. So that means this length is 1 and this length is 1. And if this length is 1, then this length has to be 1. So all you really have to do, again, is just say the absolute value of 2p is equal to, in this case, because p is 1/2, it would be the absolute value of 2 times 1/2, which is the absolute value of 1, which equals 1. So for endpoint 1, you're just going to take the focus, which is -8, -5.5, and you're going to move left by the absolute value of 2p, or you're going to move left by 1 unit. So the x-coordinate of -8 from the focus, you just subtract away 1, so that's -9, and then comma, you keep your y-coordinate the same, you're not changing that. So this is -5.5, or again, you could put -11/2 if you want. And then for the endpoint 2, we're going to take from the focus and move right by the absolute value of 2p, so we're going to move right by 1 unit. So we're going to take -8 and add 1, that would be -7, and then keep that y-coordinate of -5.5 the same. So let me come back up. So you could write this down if you didn't get it from the lesson. So the focus is the midpoint of the latus rectum, so always remember that. So the distance from the focus to each endpoint will be the same. The length of the latus rectum is the absolute value of 4p. If you're asked for that, in our specific case, if you're asked for the length, well, the absolute value of 4p is equal to the absolute value of 4 times 1/2, because p is 1/2. Let me note that up here. And this would be equal to the absolute value of 4 times 1/2 is 2. And so this would be equal to 2. So that's the length. Again, if you go back, that makes sense. This is 1 and this is 1. So 1 plus 1 would be 2. So that would be the length for the latus rectum. Then this would be the formula you need. Let me get rid of this. If you're doing this on the other problems. So for a vertical parabola, we find the endpoints as travel left from the focus by the absolute value of 2p, and then travel right from the focus by the absolute value of 2p. And then for a horizontal parabola, which we're going to have some examples of those, we find the endpoints as you travel down from the focus by the absolute value of 2p, and then you travel up from the focus by the absolute value of 2p. Okay, let's finish up the problem by just looking at the graph. I left you a link on Desmos for everything today, so you can click on that and just zoom in if you need more detail. I know that looking at these things on a screen is kind of hard, especially if you're on a phone or something like that. So this is our parabola, again, from this guy right here, and your vertex is -8, -6. So again, that's h, k. Then your focus is -8, -5.5. Again, we got that because the p value was 1/2, so we traveled a half a unit up from the vertex to the focus. Then in terms of the directrix, this is going to be y equals negative 6.5. Again, you can travel from the vertex down by a half of a unit to get to a point on the directrix, and then your horizontal line always has the same y coordinate. So because the y coordinate of that point would be negative 6.5, you can conclude that the directrix would have an equation y equals negative 6.5. Then in terms of the endpoints for the latus rectum, again, you start at the focus, which is negative 8, negative 5.5, and you move left by the absolute value of 2p. The absolute value of 2p was 1, so you move left by a unit, you get to negative 9, negative 5.5. And again, starting at the focus, you move to the right by the absolute value of 2p, so you move to the right by 1. So that gives you this other endpoint, which is negative 7, negative 5.5. All right, for problem 2, we have x equals 1/4 y squared minus 7/2 y plus 69/4. So notice that you have a y squared here. So that tells me I have a horizontal parabola, and the coefficient of that is positive 1/4, which means that horizontal parabola is going to open to the right. So this right here is going to be the form that we want to put it into, so we can get the vertex, the focus, the directrix, and the endpoints of the latus rectum. So let me start by just copying this. So we have x, I'll put a little space, is equal to 1/4 y squared minus 7/2 y plus 69/4. Okay, so I want to get everything with a y on one side, everything else on the other, just so again I can complete the square over here and match that form. So I'm going to subtract 69/4 away from each side of the equation. And so let's say this is going to cancel. So we're going to have x minus 69/4 is equal to 1/4 y squared minus 7/2 y. Now again, when you complete the square, you want the coefficient of the squared variable, in this case it's 1/4, you want that to be 1. So I can multiply 1/4 by 4, and that would be 1. So I'm just going to multiply both sides of the equation by 4. And let's go ahead and distribute this into each term inside the parentheses, and let's do the same with this one. So 4 times x is 4x, and then minus 4 times 69/4. Well, the 4s are going to cancel, and you're just going to have 69 there. So this right there would be 4x minus 69 on the left. So this equals 4 times a fourth is 1, and then times y squared is y squared. And then minus, we have 4 times 7/2 y. Well, 4 divided by 2 is 2. And then 2 times 7 is 14. So this will end up being y squared minus 14y for the right side. So now we're at the point where we're going to complete the square. Again, you're looking at the coefficient for y raised to the first power. In this case, that's going to be negative 14. Again, you want to take that sign with it because you're going to cut it in half. So negative 14 times 1/2. And then you're going to square that. The reason I'm emphasizing taking the sign with it is because when you cut this in half, that's going to give you what you need when you factor. So this right here will end up being negative 7 squared, and then negative 7 that comes from cutting this in half, that's what you use when you factor. So this will end up being the quantity y minus 7 squared. So negative 7 squared is positive 49. So this is the number we need to add to both sides of the equation to complete the square on the right. So let's say that we're going to have 4x minus 69, and then plus 49 is equal to y squared minus 14y plus 49. So again, I added 49 over here, and I added 49 over here. So on the left, you have 4x, and then negative 69 plus 49, that's negative 20. And this equals, on the right, remember this is going to factor into y, and then what's half of this? It's negative 7, so y minus 7 quantity squared. All right, so I want to factor out this 4, again, the coefficient of x right there to match my form. So let's say this is 4 times the quantity, x minus 20 divided by 4 is 5. This equals the quantity y minus 7 squared. All right, let me bring this down here, and I'm just going to switch sides. So I'll have y minus 7 quantity squared is equal to 4 times the quantity x minus 5. All right, so let's match things up. So you have a minus here and a minus here. So that means k is going to be 7. You have a minus here and a minus here. So h is going to be 5. So let me write that h is equal to 5 and k is equal to 7. Let me actually draw an arrow in each case. It's very easy to make a mistake with a horizontal parabola because we're used to h being here and k being here. A lot of the examples are vertical parabolas. The horizontal parabolas are seen less often, so just pay close attention to what you're doing. I find that taking your time and just writing things out is going to be the key to not making simple mistakes like that. Then in terms of getting the p-value, remember you're going to match this up with this right here. So I think we can tell that p is equal to 1, but we can write it out. So 4p is equal to 4, and we just divide both sides of the equation by 4 like that. And so this is going to cancel, and you get p equals 4 over 4, which is 1. So this one is p is equal to 1. Okay, so let's go down and grab our formulas. Again, you can derive these on your own if you want. I would actually suggest that you pause the video and try this on your own to come up with these formulas, just like I did with the first example. So for the horizontal parabola, the vertex is going to be h comma k. Then for the focus, that's going to be, well, now we're moving horizontally, so we're going to have h plus p. In other words, we're taking the x coordinate from the vertex and we're adding on p to get the x coordinate for the focus. And then comma, the y coordinate from the vertex is going to remain unchanged. So we're just going to have a k there because, again, we're moving horizontally, or horizontal parabola, to get from the vertex to the focus. Then for the directrix, this is going to be a vertical line now. So it's going to be x is equal to h minus p. And again, you can remember that if this is h plus p, this is h minus p. So let's grab this, come back up here and paste this in, and I'll just leave that there for reference. Again, once you understand the formulas, very easy to do these problems. So for the vertex, again, this is just h comma k. H is 5 and k is 7. For the focus, it is h plus p. H is 5, p is 1. So 5 plus 1, that's going to be 6. I'll just erase and do it now. And then comma, you want your k, which is going to be 7. Again, from the vertex to the focus, we're moving horizontally. P is equal to positive 1, so we're moving to the right from the vertex to the focus 1 unit. So here's your vertex at 5, 7. Your focus is then going to be at 6, 7. Then for the directrix, again, we follow this x equals, you have h minus p. Well, your h value is going to be 5, and your p value is going to be 1. So just 5 minus 1. 5 minus 1 is going to be 4, so it's x equals 4. Again, you can always think about the fact that I traveled from the vertex to the focus 1 unit to the right. So if I want to travel from the vertex to a point on the directrix, I would go 1 unit to the left. So a point on the directrix would be 5 minus 1 is 4, so 4, 7. And again, on a vertical line, the x coordinates are always the same, so it's just x equals 4. So again, lots of ways to think about this. You can always just use the formula. That's the quickest way. Then in terms of the endpoints for the latus rectum, I'm just going to write E1 and then E2. If you want to label it a different way, that's going to be up to you. So all we're going to do for horizontal parabola, we're going to go up by the absolute value of 2p, and then we're going to go down by the absolute value of 2p, again, starting from the focus. So the focus is 6, 7. So the x value is not going to change. So let me write 6 in each case. And we're going to go up by the absolute value of 2p. Let me put a little border here. I'm running out of room for all the stuff we have to write. The absolute value of 2p, in this case, is equal to the absolute value of 2 times 1, which is equal to the absolute value of 2, which is equal to 2. Let me extend that like that. So I'm going to take this y coordinate from the focus, which is 7, and I'm going to subtract away 2. So that's going to put me at 5. And then I'm going to take this y coordinate from the focus, which is 7, and I'm going to add 2, which is 9. So those would be your endpoints. So you're going to have 6, 5, and then 6, 9. Okay, so just coming down here to verify things with the graph. So there's our equation, and here's the graph. Again, you have a link for this if you want to look at it in more detail. Here's your vertex, which is at 5, 7. We travel 1 unit to the right to get to the focus, which is at 6, 7. Your directrix is x equals 4. Again, if you want to go from the vertex to a point in the directrix, you just go 1 unit to the left, and you'd be at a point which is 4, 7. So this vertical line right here would be x equals 4. That's your directrix. Then in terms of the endpoints for the latus rectum, you have this one here and this one here. If you want this one, which is 6, 5, again, starting at the focus, you're moving down by 2 units because the absolute value of 2p was 2. So that gives you this one right here. And then starting from the focus and going up by 2 units, you get this other endpoint, which is 6, 9. All right, for problem 3, we have y equals 2x squared minus 20x plus 46. So this is going to be a vertical parabola. I know that because this is x squared right here. I also know it's going to open up because this is a positive 2 as the coefficient for x squared. So I'm going to use this form right here. And so let me just copy this. This would be y, I'll leave a little space. This equals 2x squared minus 20x plus 46. And again, we're going to get all the terms with x on one side, everything else on the other. So let me subtract 46 away from each side of the equation. And so this is going to cancel right there. And so on the left, you have y minus 46, and this equals, on the right, you have 2x squared minus 20x. Again, when you complete the square, you want the coefficient of the variable that's squared, in this case it's x squared, to be a 1. Right now it's a 2, so you can multiply both sides by a half, or you can divide everything by 2. It's really up to you. I think dividing everything by 2 is probably simpler. So let's just do it that way. So y over 2, let's write that as 1/2 y, and then minus, if I think about 46 divided by 2, that's 23. So let's write 23 right there, and this equals, over here, the 2's would cancel, so you just have x squared there, and then minus 20 divided by 2 is 10, so this would be 10x. So you get 1/2 y minus 23 is equal to x squared minus 10x. All right, so now we want to complete the square. So I'm looking at this coefficient right here. So on my x raised to the first power, so that's -10. So you're going to cut it in half and then square it. So we're going to take -10 times 1/2, and then we're going to square that. So this equals -10 times 1/2 is -5. So -5 squared, which is 25. Again, remember that -5 because you need that when you factor. This guy's going to end up factoring into the quantity x minus 5 squared. So I'm going to add 25 to both sides of the equation, and that's going to give me 1/2 y minus 23, and then plus 25 is equal to x squared minus 10x plus 25. Okay, so I added 25 over here, so I've got to add 25 over here. And so now we have 1/2 y. -23 plus 25 is going to be 2. So plus 2 is equal to, over here, remember this is going to factor into the quantity x minus 5 squared. The -5 is coming from cutting this -10 in half. That's how you get that. So then I'm just going to factor out the coefficient of y, which is going to be 1/2 in this situation. So I'm going to say this is 1/2 times the quantity, y, and then plus, you're going to divide 2 by 1/2, which is going to give you 4. Now, if that's confusing for you, you can also think about what would I need to do to undo multiplication by 1/2? Well, I would multiply by 2. So you can also just take 2 and multiply by 2 to get to 4. Either way you want to do it. I know when you factor out something that's a fraction, a lot of times it's a little bit confusing. So this is equal to, over here we have the quantity x minus 5 squared. Okay, let's go ahead and grab this. And let's paste this right here. I'm going to make this match. I'm going to switch sides here. So let's write the quantity x minus 5 squared. And let's say that this is equal to, over here I have 1/2 times the quantity. Instead of y plus 4, let's write y minus a -4, like that. So let's erase this. And again, just match things up. So now your h is going to be 5 and your k is going to be -4. Again, that's because I matched up this minus with this minus, this minus with this minus. So h is 5 and k is -4. H equals 5, k equals -4. So what is the p value going to be? Again, you're going to match this up with this right here. So we're going to say that 4p is equal to 1/2. And we can multiply both sides by 1/4 or divide both sides by 4, whatever you want to do there. So let me multiply both sides by 1/4. I think that's easiest. So this would cancel and give me 1. So you basically get that p is equal to 1/2 times 1/4. That is 1/8. Okay, let me actually erase this and I'll just write it more cleanly. So p equals 1/8. So if you need the formula, we can just grab it from here. So for the vertex, this is going to occur at h, comma, k. For the focus, this is going to be h, comma, k plus p. For the directrix, this is going to be y equals k minus p. Okay, let's come back here and paste this in. And let me put a little border here. And so we'll say that the vertex is going to occur, again, at h, comma, k. H is 5, k is -4. The focus is going to be at h, which is 5, comma, k plus p. K is going to be -4, and p is 1/8. Now this one, again, you could do it with a calculator, and you're going to get -3.875, or you can work with fractions. That's going to be up to you. You could say that -4 is -32/8, and then plus 1/8. So this would be -31/8. So whatever form you want to use, it's up to you. I'm just going to stick with fractions because that's what we used for the practice tests. But if you want to use a decimal in that case, that's up to you. So this would be 5, -31/8 or 5, -3.875. For the directrix, this is y equals your k value, which is -4, and then minus your p value, which is 1/8. If you wanted to punch that into the calculator, you get -4.125. So you could do it that way, or you could say -4 is -32/8, and then minus 1/8. So this would be -32 minus 1. That's -33, and this is over 8. So let's say y equals -33/8, or again, -4.125. Now, in terms of the endpoints for the lattice rectum, let's do E1 and E2. We have a vertical parabola. So that means we're moving from the focus to the left by the absolute value of 2p and to the right by the absolute value of 2p. My y-coordinate in each case will be the same. It's not going to change. So it's -31/8 and -31/8. Let me see if I can make that a little bit cleaner. The absolute value of 2p is going to be equal to, again, p is 1/8. So it's the absolute value of 2 times 1/8. So this right here, 8 divided by 2 is 4. So this is the absolute value of 1/4, which equals 1/4. So what you're going to end up doing is you're going to take 5 and you're going to add a 4th. So basically it's 5.25 if you want to do that as a decimal, and then you're going to subtract away a fourth. So that would be 4.75, again, if you want to do that as a decimal. If you want to work with fractions, then you're going to do 5 as 20 over 4, and then minus 1/4. So that is going to be 19 fourths. Again, that's your 4.75. So this is 19 fourths. And then you can also take 20 over 4 and add a fourth. So this would be 21 over 4. So that's your 5.25. So this is 21 over 4. Let me actually make this bigger like that. All right, just coming down to the graph to verify things. So this is our equation right here, and this is going to be our parabola. So the vertex, and I know this is a little bit small, but it's at 5, -4. The focus is at 5, -3.875. So again, the p-value was 1/8, so we traveled up by 1/8 of a unit to get from the vertex to the focus. Similarly, we can travel down by 1/8 of a unit to get from the vertex to a point on the directrix. So that point would be 5, -4.125. So that means this horizontal line right here would be y equals -4.125. And then you have your endpoints for your latus rectum. So you have this one right here, and then this one right here. So this one on the left, again, you just start with your focus and you move left by the absolute value of 2p. Well, the absolute value of 2p was a fourth. So you're moving left by a fourth, which gives you 4.75, -3.875. And then again, starting from the focus, you're going to move right by a fourth. So that gives you 5.25, -3.875. All right, for problem 4. We have y equals -1/4 x squared minus 3x minus 15. So here we have x squared, so that's going to be a vertical parabola, and this -1/4, which is the coefficient of x squared, the fact that it's negative tells me that this is going to open down. So let's come down here and let's write this again. So let's just write y, I'll leave a space, equals -1/4 x squared minus 3x and then minus 15. So again, I want to end up with this quantity x minus h squared on the left. So I'm going to need to complete the square. So I'm going to keep all the terms with an x involved on one side, move everything else to the other. So let's add 15 to both sides of the equation. So this is going to cancel. So I'm going to say that we have y plus 15 is equal to -1/4 x squared and then minus 3x. Now I want the coefficient of x squared to be 1. Right now it's -1/4. So to fix that, I can multiply both sides of the equation by -4. Let me move this down here. This is going to get distributed in, and this is going to get distributed in. So -4 times y is going to be -4y. Then -4 times 15 is going to be -60. And then this equals, over here, -4 times -1/4 is 1. Then times x squared would be x squared. And then -4 times -3x is going to be plus 12x. So here's where I'm going to complete the square. So again, I'm looking at the coefficient of x to the first power, which is 12. I'm going to cut it in half, and then I'm going to square it. So we're going to say that we have 12 times 1/2 squared. This equals 6 squared, which is 36. Remember, keep that number 6 in mind because when you factor, you need that. This is going to turn into x plus 6 quantity squared. So we're going to add 36 to both sides of the equation. So we have -4y minus 60 plus 36, let me fix that, is equal to x squared plus 12x plus 36. So I added 36 on the left, and then I added 36 on the right. On the left, you have -4y minus 60 plus 36. So -60 plus 36, that's -24. So let's write this as -4y and then minus 24. So that's the left side. Then this equals on the right side. Again, you're going to factor this into x plus half of this is 6, quantity squared. All right, so now we're going to factor out the coefficient of y, which is -4. So this is going to be a -4 out in front. Inside the parentheses, this is y. And then -24 divided by -4 is positive 6. So we'll put plus 6 here. We'll say this equals the quantity x plus 6 squared. Okay, so we want to match things up. So I'm going to move this over here. So let's say this is the quantity x. Instead of plus 6, let's write minus a -6. This is quantity squared is equal to, this would be -4 times the quantity. Instead of y plus 6, let's write y minus a -6. And again, let's match things up. So your h is -6. This is a minus, this is a minus. And then your k is -6. Again, this is a minus and this is a minus. So this right here, I'll just arrow. And same thing right here, I'll just arrow. So we'll say that h is equal to -6. And then k is equal to -6 as well. All right, to get p, we're going to match this up with this. So let's say that 4p is equal to -4, and we'll divide both sides of the equation by 4, and so this is going to cancel, and you're going to get p is equal to -4 over 4 is -1. So let's go down here. Again, we're working with a vertical parabola. So the vertex is h comma k. The focus is going to be h comma k plus p. And then the directrix, again, is y equals k minus p. Let's grab this and let's come back and paste this in. And let me put a little border here. So for the vertex, again, this is h comma k. Well, h is -6 and k is -6. And then for the focus, again, this guy opens down. So this p equals -1, that tells me that I'm traveling down by 1 unit from the vertex to the focus. So this is going to be -6. Again, it's h. You're keeping that same x coordinate. And then comma, k plus p. Well, your k value is -6 and your p value is -1. So -6 plus -1 is -7. So if I start at the vertex, which is -6 comma -6, and I travel down by 1 unit, I'm going to get to the focus, which is -6 comma -7. Again, always go back to the definition that p is the directed distance from the vertex to the focus if you forget your formula. Then for the directrix, again, it's just going to be y is equal to your k value, which is -6, minus your p value. Be very careful here because this is a negative. So minus a -1, again, that's +1. So this becomes -6 plus 1, which equals -5. Does that make sense? Yes. Because if I'm going 1 unit down to get from my vertex to my focus, that means I'm going to go 1 unit up to get from my vertex to a point on the directrix. So that point would be -6 comma -5. And again, because this is a horizontal line, all the y coordinates are the same on the directrix. So you just have y equals -5 for your directrix. All right, let me put a little border here. And we're going to grab our endpoints for the latus rectum. So I'm just going to go E1 and then E2. And all we're going to do, let me slide down a little bit so I have some room. We're going to think about the absolute value of 2p. Again, in this case, p is equal to -1. So this would be the absolute value of 2 times -1, which would be the absolute value of -2, since 2 times -1 is -2, and the absolute value of -2 is +2. So because we have a vertical parabola, we're going to start at the focus, and we're going to go 2 units to the left, and then we're going to start at the focus, and we're going to go 2 units to the right. So if I start at -6 comma -7, and I go 2 units to the left, I'm just taking this x coordinate of -6, and I'm going to subtract away 2. So -6 minus 2 is -8. So this would be -8, comma, -7. Again, if I start at the focus and I go 2 units to the right, I'm going to take this x coordinate of -6. I'm going to add 2. So -6 plus 2 is -4. So this would be -4, comma, -7. So that would be your 2 endpoints for the latus rectum. Okay, let's come down here and look at the graph. So there's our equation. And so the vertex is at -6 comma -6. The focus is at -6 comma -7. Again, we travel down 1 unit because p equals -1 to get from the vertex to the focus. Then similarly, your directrix is this horizontal line y equals -5. So I'm going to travel 1 unit up to get from the vertex to a point on that directrix. So that point would be -6 comma -5. And again, because we're on a horizontal line, all the y coordinates are the same. So that gives me that y equals -5. Now, in terms of this endpoint right here and this endpoint right here for the latus rectum, you start at your focus and you're going to go to the left by the absolute value of 2p. Remember, the absolute value of 2p was 2. So we're going to the left by 2 units. So that puts me at -8 comma -7. And then starting at the focus, I'm going to go to the right by the absolute value of 2p, which is 2 in this case. So that's going to put me at -4 comma -7. All right, for problem 5, we have 2x squared minus 12x minus y plus 22 is equal to 0. So we're going to take this guy right here and again, put it into this form right here. And the way I know I'm using the form for the vertical parabola is because this is x squared right here. And so basically, you're going to take everything with an x and keep it on one side, and everything else is going to go to the other. So for this one, let me just write 2x squared minus 12x minus y plus 22 is equal to 0. And so what we're going to do is add y to both sides of the equation, and we'll subtract 22 away from each side of the equation. So let's say that this will cancel and this will cancel. So we're going to have 2x squared minus 12x, and then this is going to be equal to, over here I'm going to have y minus 22. Now again, you want the coefficient of your variable that's squared, in this case it's 2, you want it to be a 1. So you can multiply both sides by a half, or you can divide everything by 2. I think it's probably easier just to divide everything here by 2. So let's go through here and say that 2 over 2 is 1. So this would be x squared. And then minus, if you think about 12 over 2, that's 6. So this would be 6x. And then this equals, over here you have y over 2. Let's just write 1/2 y. And then you have minus, this 22 over 2 is going to be 11. So let's put 11 right there. All right, so now we have x squared minus 6x is equal to 1/2 y minus 11. So what I'm going to do is complete the square. So again, I'm looking at this right here. the coefficient for x to the first power. I'm going to cut it in half and then square it. So we have -6 times 1/2, and then we're going to square that. So this becomes -6 times 1/2 is -3. And if we square this, this is 9. So I'm going to add 9 over here and add 9 over here. So let me erase this, and let's go +9 right here, and then +9 right here. So I added 9 here, and then also here. So this left side is going to factor into x, and then half of -6 is -3. So x minus 3, quantity squared, is equal to 1/2 y, and then -11 plus 9, that's going to be -2. So again, I want to factor out this coefficient of y, which is 1/2. So let me write the quantity x minus 3 squared is equal to, if you pull this out, inside the parentheses you have y and then minus. Again, you could divide 2 by 1/2 and get 4. Or you can also think about it as, what do I need to do to undo multiplication by 1/2? I need to multiply by 2. So take 2, multiply by 2, and you get to 4. If you struggle with this with fractions, you can just distribute it back in. 1/2 times y is 1/2 y, minus and minus. 1/2 times 4 is going to be 2. So you can just check it that way if you're a little bit unsure. And we'll paste this in here. So your h is going to be 3, and your k is going to be 4. Let me just arrow to these so it's clear. So h is equal to 3, and then k is equal to 4. We have to get the p value. So 4p is going to be set equal to 1/2 because we're matching this with this. So we would divide both sides of the equation by 4, or it's probably easier here just to multiply both sides by 1/4, since we have a fraction over here. So that'll cancel, give me 1. So 1 times p is just p. So p is equal to 1/2 times 1/4 is 1/8. So this right here is going to be p is equal to 1/8. So we have a vertical parabola, so we're going to use this one right here. So the vertex, again, is h, comma, k. The focus is going to be h, comma, k plus p. And the directrix is going to be the horizontal line, y equals k minus p. All right, let's come back and paste this in, and I'll put a little border. So for the vertex, we're going to say that it's h, comma, k. H is 3, and k is 4. So it's 3, comma, 4. For the focus, it's h, which is 3, comma, k plus p. So this is 4 plus 1/8. So that would be 4.125 if you want to use a decimal. Or if you're using fractions, you can go 32 over 8. So that's just 4, written with a denominator of 8, then plus 1/8. So this is 33 over 8, just doing 32 plus 1, that's 33, over the common denominator of 8. So let's write this as 33 over 8, or again, if you want to do 4.125, that's up to you. And then for the directrix, this is going to be y equals, you're going to have k minus p. So it's going to be 4 minus 1/8, so that's going to be 3.875 if you want to use a decimal, or again, you could just go 32 over 8 minus 1/8. 32 minus 1 is 31, over the common denominator of 8. So this is 31 over 8. So let's write that like that. Okay, in terms of the endpoints for the lattice rectum, let's go E1 and E2. Again, because this is a vertical parabola, you're moving to the left from the focus by the absolute value of 2p, and then to the right from the focus by the absolute value of 2p. Well, the absolute value of 2p is equal to, here p is 1/8, is the absolute value of 2 times 1/8. So 8 divided by 2 is 4. So this is the absolute value of 1/4, which is 1/4. Let me write this. Maybe I'll move this down just a little bit. The y coordinate in each case is not going to change. So it's going to be 33 over 8. So I'll just put that in now. That's easy to get. Then you're going to take 3 in, subtract away a 4th. So you could put 2.75 if you want. And then you're going to take 3 and add a 4th. So you could put 3.25 if you want. Or we can do this with fractions. So you could say 12 over 4 minus 1/4. So that's 11/4. So again, that's 2.75 as a decimal. And then you could just change this to plus. So 12/4 plus 1/4. That is 13/4. And so that is going to be 3.25 as a decimal. So let me put that in there. And let's just come down here and verify things. So this is going to be our graph. So your vertex is at 3, 4. Your focus is at 3, 4.125. Again, you're traveling up because your p-value is 1/8. So you're traveling up by 1/8 of a unit. So that's why the y value goes from 4 to 4.125 when you go from the vertex to the focus. Then similarly, from the vertex to a point on the directrix, you could just go down by 1/8 of a unit. So your y value for this point on the directrix would be 3.875, and the x value would still be 3. So y would just be equal to 3.875 because the y values are always the same on a horizontal line. Then in terms of this endpoint right here, you're just going from the focus to the left by the absolute value of 2p. Remember, the absolute value of 2p was 1/4, so you're going to the left by a fourth. So this would be 2.75 comma 4.125, and then you're traveling from the focus to the right by the absolute value of 2p, so you're going to the right by a fourth. So this would be 3.25 comma 4.125. All right, let's take a look at problem 6. So we have negative 1/8 y squared plus 3 halves y minus x minus 17 halves is equal to 0. So this has y squared in it. So that tells me this is a horizontal parabola. And so we're going to use this form right here. Let me just copy what we have. So negative 1/8 y squared plus 3 halves y minus x minus 17 halves is equal to 0. Okay, so once again, I want everything with a y on one side, everything else on the other. So let's add x to both sides of the equation, and let's add 17 halves to both sides of the equation. So we'll go ahead and cancel this and cancel this. So we're going to say that this is negative 1/8 y squared. Let me fix that. And then plus 3 halves y. And this equals, we have x plus 17 halves. Now again, we want the coefficient of y squared, because we're going to end up completing the square, to be 1. Right now it's negative 1/8. So to fix this, we're going to multiply both sides of the equation by negative 8. Let me actually slide this down just a little bit so I can squeeze that in. So this right here is going to get distributed to each guy inside the parentheses. And this guy is going to get distributed to each guy inside the parentheses. So negative 8 times negative 1/8 is 1, then times y squared is y squared. Then negative 8 times 3 halves y, let me write that out. I'm going to go plus negative 8 times 3 halves y, just so we can see this. So we know that 8 divided by 2 is 4. So we would say that this would cancel with this, and let's put a negative 4 there. So negative 4 times 3 is negative 12. So let's write this as minus 12y. We will put y squared minus 12y for the left, and this equals, on the right, negative 8 times x is negative 8x. And then we would also have, let me go plus negative 8 times 17 halves. So we can see this one. So this would cancel with this. 8 divided by 2 is 4. So let's put this as a negative 4 here. So then negative 4 times 17, that's going to be negative 68. So let's write minus 68 here. And actually, let me slide this down just a little bit, just so we have room to add our number in there. All right, so we're going to complete the square. So we want to cut this number right here, that negative 12, which is the coefficient of y, in half, and then we want to square it. So what is negative 12 times 1/2 squared? So this is negative 12 times 1/2, that's negative 6. And if we square that, we get 36. Again, just keep that negative 6 in mind because that's what you're going to use when you factor. So let's go ahead and say that this is plus 36 here, and this is plus 36 here. So all I did was I added 36 over here, and I added that over here. So sliding down, we're going to now factor this left side into y. Again, half of this is negative 6, so minus 6, quantity squared. And this equals, over here, you have your negative 8x, and then negative 68 plus 36, that's going to be negative 32. Let's factor out this negative 8, which is the coefficient of x right there. So we're going to have the quantity y minus 6 squared is equal to negative 8 times the quantity, x, and then negative 32 divided by negative 8 is plus 4. Okay, let me bring this down here. We're going to match things up. So this is a minus and this is a minus, but this is a plus and this is a minus. So I'm going to change this to minus a negative 4. Again, just so things match up. So now k will be 6 and h will be negative 4. Pay close attention, again, when you have a horizontal parabola, it's very easy to make a mistake. I'm just going to draw an arrow and draw an arrow, and I'm going to say that h is negative 4. And then k is positive 6. So the p-value here, you're going to solve 4p equals negative 8. Again, that's coming from this being matched up with this. So let's say 4p is equal to negative 8. And so we're going to divide both sides of the equation by 4. So this would cancel, and you're going to get p equals negative 8 over 4, which is negative 2. So p is equal to negative 2. We're working with a horizontal parabola. So for the vertex, again, it's h comma k. For the focus, now we're going to have h plus p comma k. And then for the directrix, this is a vertical line. So it's x equals h minus p. All right, let me paste this in right here, and I'll put a little border for us. So the vertex is going to occur at h comma k. H is negative 4 and k is positive 6. For the focus, remember, this p right here is the directed distance from the vertex to the focus. This is a horizontal parabola, and because this is negative, it opens to the left. So that means we're traveling from the vertex 2 units to the left to get to the focus. So we're going to take this x coordinate here, which is -4, and we're going to add -2, which is going to give us -6. Again, just following the formula, h is -4, and then plus p is -2. So -4 plus -2, that's -6. And then the y value from the vertex is not going to change. So you're just going to have k there. So this is going to be 6. Then for the directrix, again, if I went to the left by 2 units to go from the vertex to the focus, I would go to the right 2 units to get from the vertex to a point on the directrix. So that means that the x coordinate of that point would be -2, right? So the point would be -2, 6. So because on a vertical line, all the x values are the same, you just say it's x is equal to, again, -2. Or you can get that as h minus p. So what is h? That's -4. And then what is p? That's -2. Be very careful. You have a minus there. So minus a -2. Be very careful with this formula. I see a lot of people making a mistake. So this is -4 minus a -2 is +2. So this is -4 plus 2, which is -2. Again, you can always just use the definition if you forget the formula. So this is x equals -2. Now in terms of the endpoints for the lattice rectum, again, let's write E1 and E2. The absolute value of 2p here is going to be, well, p is -2, so it's the absolute value of 2 times -2, which is the absolute value of -4, which equals 4. So this is a horizontal parabola. That means I'm traveling up from the focus by the absolute value of 2p units and down from the focus by the absolute value of 2p units. So I'm going up from the focus by 4 units and down from the focus by 4 units. So the focus is -6, 6. So the x coordinate would stay the same. It's going to be a -6 here and a -6 here. And then you're just going to take this y coordinate of 6 and you're going to subtract away 4. 6 minus 4 is 2. And then you're going to add 4. 6 plus 4 is 10. So those are your endpoints. All right, let's come down to the graph and just verify things. So this is going to be for this guy right here. So we have our vertex, which is at -4, 6. The focus is at -6, 6. Again, the p-value was -2. So we traveled 2 units to the left to get from the vertex to the focus. If we want to get from the vertex to a point on the directrix, we would go 2 units to the right. So this point right here would be -2. That comes from -4 plus 2, and then comma 6. But again, this is a vertical line, so all the x values are the same, so it's just x equals -2 for the directrix. You have your endpoints for the lattice rectum. Again, those are found by starting at the focus and going up by the absolute value of 2p, and then going down by the absolute value of 2p. And in this case, the absolute value of 2p is going to be 4. So we go down by 4 units, we get this -6, 2. And then if we go up by 4 units, we get this -6, 10. All right, we're going to change up the instructions now. So we want to write an equation for the parabola. All right, for problem 7. We are given that the vertex occurs at -10, -1, and the focus is going to be at -15 halves, or you could say -7.5, -1. Now, for this one, you're going to end up using this form right here. How do I know that? Well, this is going to be for a horizontal parabola, because this right here is -1, that's a y coordinate, and this right here is -1. Again, when we travel from the vertex to the focus, if we're traveling horizontally, because the y values are not changing, well, that tells me that this is a horizontal parabola. The axis of symmetry here would be y equals -1. So all you have to do is actually just plug in. The biggest stopping point here is you have to figure out what p is, but we'll get that in a moment. So let me plug in y minus, what is k here? Again, the vertex is h, k. So the h value, let me put this off to the side. The h value is -10. Again, that's the x coordinate here. And the k value is -1. That's the y coordinate here. So what we're going to do is plug in for k. K is -1. Minus the -1, you can go +1. This is quantity squared. And this equals 4p times the quantity x minus h. H is -10. Minus the -10 is +10. Now, as I said before, the biggest issue is getting p right here. So how do we figure that out? Again, go back to the definition. P is the directed distance from the vertex to the focus. What I would do, you can eyeball this and do it. And I know once you get some practice, it'll be easy to do. But if you're just starting and you don't understand this, just go to the coordinate plane and plot each one. You can do this on Desmos. I'll actually leave you a link for it. But essentially, this is your vertex. It occurs at -10, -1. So that's right there. This is your focus. It occurs at -7.5, or you could say -15 halves, -1. If you just think about this, we know this is a horizontal parabola. So this would look something like this. And this isn't going to be accurate. I'm just doing this for visualization. We know that from the vertex to the focus, we're going to travel to the right. So that means this guy opens to the right, and we want a p-value that is positive. Well, how do we get a positive when we get this distance right here? We take the larger and we subtract away the smaller. So I'm going to take -7.5, which is the larger here, and subtract away the smaller, which is -10. And so this would be equal to -7.5 minus the -10 is +10. And so this equals positive 2.5, or you could write 5/2 if you're working with fractions. So that tells me that the p-value there, or the directed distance from the vertex to the focus, is 5/2 or 2.5. Okay, so come back up, and I'm just going to put that p is equal to 5/2, and then you can just plug that in. Let me actually move this down so it fits. So times 5/2, and we'll do a little bit of simplifying, and we'll be done. So this is the quantity y plus 1 squared is equal to 4 divided by 2 is 2. 2 times 5 is 10. So this is 10 times the quantity x plus 10. All right, let's take a look at problem 8. So here we're given that the vertex is -3, 6, and the focus is at -25/8, 6. So once again, we know we have a horizontal parabola. This y-coordinate is 6, this y-coordinate is 6, so we're traveling horizontally to go from the vertex to the focus. So we're going to use this guy right here. So you just plug in what you know. Let me put this off to the side. H is equal to what? It's the x-coordinate from the vertex, so -3. K is equal to, it's the y-coordinate from the vertex, so that's 6. And we'll just plug in, so y minus k. K is 6, so minus 6, quantity squared, equals 4p times the quantity, x minus h. H is -3, so minus the -3 is plus 3. We need to get p. So again, that's where I would plot this one and this one. So -25/8, that's -3.125. So this is going to be really hard because they're so close together. Again, I gave you that link on Desmos. You can zoom way in if you want to get some distance, but essentially you can see that this guy is going to open to the left. So it's going to do something like that. So you're traveling from the vertex to the left to get to the focus. So that means that the p-value is going to be negative, right? Because it's a directed distance. So how do I end up with something that's negative? Well, I want to take the smaller minus the larger. So I'm going to take this -3.125 and subtract away this -3 here. So smaller minus larger. Again, this is smaller because it's to the left on the number line. So this would be equal to -3.125 plus 3. So this is equal to -0.125, or you could say -1/8 if you're working with a fraction. So coming back up, we'll say p is equal to -1/8, and we'll just plug that in right there. Let me actually just rewrite this. So this is x plus 3 right there. So this is times -1/8. 8 divided by 4 is 2. So let's slide down and just simplify. This is the quantity y minus 6 squared is equal to, this is -1/2 times the quantity x plus 3. All right, for problem 9, we are given a vertex which occurs at -5, 10, and then a point on the parabola, which is 0, 9, and we're told that it's horizontal. So we're going to use this guy right here. This is actually a lot easier. You just plug in pretty much everything and solve for p. So you don't have to go through and do any plotting on the coordinate plane or anything like that. It's very straightforward. So let's put that h is equal to, again, that would be -5. It's the x-coordinate from the vertex. K is equal to positive 10. It's the y-coordinate from the vertex. And then you have a point. So I'll just say PT for point. And I'm going to say that x is equal to 0 and y is equal to 9. So that's just coming from this right here. This is the x-coordinate. This is the y-coordinate. So that's where this is coming from. So you plug in everything at first and then just solve for p. So for y, you plug in a 9. And then minus for k, you plug in a 10. This is quantity squared. And this equals, we don't know what p is. So let's put 4p times the quantity. For x, you're plugging in a 0. And then minus for h, you have a -5, so minus the -5 is plus 5, and then close that down. We know that 9 minus 10 is -1, so this would be -1 squared is equal to 4p times, this would be 0 plus 5, which is 5. And so -1 squared is 1, so you get 1 is equal to, 4 times 5 is 20, so this is 20p. And then to finish things up, divide both sides of the equation by 20, and of course this would cancel, and we could say that p is equal to 1 over 20. And let me write here that p is equal to 1 over 20. So now you can say y minus, again, your k is 10, quantity squared, is equal to 4 times 1 over 20. Again, just plugging that in for p, and we can think about 20 divided by 4 is 5. So this ends up being 1/5 right here. And times the quantity, x, and then minus h. H is -5, so plus 5. So that's our equation. All right, for problem 10. We have a vertex that occurs at -10, -4, a point that's given on the parabola, which is -8, -20. We're told that it's a vertical parabola, and so we're using this form right here. So just like we did in the last problem, we're just going to plug in what we know. So we have that h is equal to, again, it's the x-coordinate from the vertex, so that's -10. K is equal to, it's the y-coordinate from the vertex, so that's -4. And then you have a point that's given. So this is x is equal to, again, this right here is your x-coordinate, so that's -8. And then y is equal to, this is y right here, so that's -20. All right, so we want to plug in what we have and then just solve for p. So x is -8, and then minus h. H is -10, minus the -10 is plus 10. This is quantity squared, and this equals 4p times the quantity. Y is going to be negative 20, and then minus k. K is negative 4, so minus the negative 4 is plus 4. So negative 8 plus 10 is 2, so this would be 2 squared. And this equals, let me write 4 times negative 20 plus 4 is negative 16, and then times p. 4 times negative 16 is negative 64. So let's say that this is 4 from 2 squared is equal to, this would be negative 64, again from 4 times negative 16, and that's times p right there. So to get p by itself, let's divide both sides of the equation by negative 64. And let me actually fix this. This would cancel, and so what we're going to get is that p is equal to, this would be negative, well, 4 divided by 4 is 1, and then 64 divided by 4 is 16. So this is p equals negative 1 over 16. So let me put p equals negative 1 over 16, and let me make that a little bit better there. So this right here turns into the quantity x minus, your h value is negative 10, so minus the negative 10 is plus 10, quantity squared, is equal to 4 times p. P is negative 1 over 16. So 16 divided by 4 is 4. So this is negative 1/4. And then times the quantity, y minus k. So k is negative 4, minus the negative 4 is plus 4. So that's our equation.